That's cool.
So should we continue Matrix, or maybe we can quickly update about the Kubernetes speakers?
Oh, okay.
I haven't joined it. We can.
Yeah, my discussion's more open-ended, so maybe it makes sense to start with.
Just quick update.
Oh, okay. That's trying to. Okay. Share my screen. I think your mic is not. Okay. Let me share my screen. This quarter we're mainly focused on 4 things. The first one is let me show the dashboard. The first one is set up all the test suite for Kubernetes. So today we already have almost all the test suite for Kubernetes. You can see most of them are green, and there are several ones. It's red. Actually, it is not before the holiday, so there seems to be something wrong. I will look into it, but most of them are red. Are green. Sorry. Yeah. So actually, before this quarter, there are only 206 test failures, and we understand of them. But now there seems to be some more, so I need to look into it. So that's one thing. Almost all the E2E tests are passed, including for example, the alpha features and the device plugin of them. So that's the first thing we focused on. We focused on this quarter, and another one is performance. So we made some performance improvement and set up the continuous integration task. So if you are interested, you can take a look at this dashboard. So based on our current result, almost all the metrics are a bit better than Docker. But there's one exception: is the container runtime memory usage, because the new Kubernetes stream has higher memory usage than old Kubernetes stream. So if you compare old Docker with CR Kubernetes, the memory usage is CR Kubernetes memory usage is overall memory usage is still a little bit higher because the Kubernetes stream use more memory. But if you compare CR Kubernetes with new Docker, the one used new Kubernetes, so it should be similar. Other than that, other metrics are all a bit better than Docker. That's for the performance side. And then another one we want to do this quarter is to merge the 2 projects to let Kubernetes vendor CR Kubernetes. So for this one, we already finished most of the code, so it's already possible today. We have a pending PR ready for review, and already got some comments here. So we plan to merge this quarter. So after merging this, it means that if you start Kubernetes, it will natively support CRI, and you can just use it with Kubernetes. That's the third thing. And the last one is some CRI improvement, including the storage identifier we discussed several weeks ago. And there's one PR I want to mention, the container log rotation. I sent out the PR last week, and already got some review from Dashboard and Toffen. And if you care about this part, or you are interested in this area, please take a look. So after this one is merged, Qubit will be responsible to rotate container log. It's not some third-party log rotator or the container runtime. So Qubit will do it.
But only for remote runtime.
Yeah, only for CRI remote runtimes. Yeah.
So yeah, so the last thing is CRI improvement, and the only thing left for this quarter. There are two things left for this quarter. One is this log rotation. Another one is container log stats. That's why we also have a PR. Yeah, so it's this one. So what this one does is that previously Kubernetes get container log stats. How large is container log? Disk usage from the from supervisor. Because now Kubernetes knows where is the container log, and CRI defines the log path. So actually Kubernetes can very easily do that. We already have the library. So this PR, this PR does is to let Kubernetes power a very simple library, a DU library to get the disk stats of the container log. So those are the two things left for this quarter, two CRI changes left. And I think that's the current status. The tests are almost green, but after the holiday, there are several test failures, and the performance is much better than earlier this quarter. And the merging is finishing soon, and the CRI improvements are almost done. There are only two pending PRs left. That's it. Any question, comments? Okay.
Nice progress.
Yeah.
So can we also schedule another status update with the cloud next week? So
Yeah. I think we can do that. I guess I was just chatting with Ronaldo in the background. I think we had wanted to integrate with the Node Perf dashboard, but I think that's not possible right now. Unless you're running your test on the GCE hosted infrastructure. Is that a correct understanding?
Is it possible when you're not running on the test infrastructure to integrate with the Node Perf dash? Do they just need to upload their results somewhere, or?
Yeah. So what Perf Dash does is that it downloads. Today it downloads the test the test result from GCS, some GCS bucket. But actually, you can point it to somewhere else.
you also can upload. You could generate those performance and upload it to the GCS bucket.
But to do comparisons wouldn't be accurate. Like I think that unless we're all running in the same environments, right?
Yes. Same environment. Yeah. So far, at least all is on the same test. Yeah, underneath infrastructure.
Okay. Yeah, I think whether Manal or Antonio, either one of them would be happy to give an update on next week.
Cool. So and also we mentioned that before Yuju's vacation, and actually she's working on the testing metrics for all the container runtime, so that everyone can pick up the test and conform test and future test and run against all of the runtime. So then we can generate off the release grade and the test grade first. We can generate a release grade. Once we have all those runtimes production ready, so this is why we want to at least have the two runtime, like what we sponsored through the CI interface effort, and we could follow those kind of steps.
Yeah, that sounds great, and we're happy to do whatever's needed there.
Cool. So, any other question? So I think the Patrick from the Sig Windows, they ask some for the per container stats.
Yeah, I listen. Okay. Send it here.
Okay, now Tim, you are on. Let's continue.
So this is a follow-up discussion of the sandbox isolation document that I introduced last week. Hopefully more folks have had a chance to take a look at that. I did want to mention I got a lot of feedback around the use cases and it being hard to understand the differences and the requirements between those. And so I reorganized that section a bit to kind of better capture the different requirements. A lot of those kind of sort of security requirements are not really well defined. You know, it's not clear why one use case needs higher security than the other. It's going to depend a lot on a case-by-case basis. So I was just kind of thinking a little more generally, just to give a general idea. I didn't want to get too caught up in the details on those. Yeah, I guess moving forward, I think the largest open question that I have is what level the sandboxing should be at, if it should be the pod level or the container level. And I think a lot of the remaining open decisions sort of, once that's decided, those will sort of fall into place as kind of implementation details almost from that. And so that's been a big focus for a lot of the discussions that I've been having. And I wanted to kind of get some feedback from this group, if anyone has thoughts on that. And then just quickly, I'll mention two other topics that I'd like to discuss if we have time, is the plugin model, specifically around general device support and daemon sets, and also a little just touch on lifecycle, which might sort of fall out as an implementation detail from the sandbox level discussion. But yeah, I'll open the floor to questions or comments now.
I think it's too many. Maybe do you want to show people like the sandbox layer? And since you want to focus on that one,
sure.
so then also can summarize what we are offline discussing. Say basically we are down to the sub pod, 2 pod. You can explain that.
Yeah.
Then we can continue there.
Okay.
Yeah. Otherwise it's too wide open.
Fair.
So it's like, yeah, I don't know if you can swap it out whole, but I think it will end up being like for different use cases. Yeah, not ideal. Well, yeah, so there's the potential of like having tests that use infosets as the package. That's an interesting question too, especially with sourcing. With infosets. I don't know the details. Sorry. All right, what's up?
We go to the sandbox there.
So that will give you.
Yeah, so the sandbox layer is referring to what kind of place in the container pod node cluster hierarchy we want to enforce this secure isolation idea. And I listed out a number of different options here. And after some offline discussions, we were feeling like container subpod and this kind of container pod hybrid approach are all fairly similar in the design complexity, the implementation complexity. But this subpod approach is by far the most flexible and powerful. And so we were feeling like if we decide that we need to, if we decide that this subpod isolation is something that we really need to support, that this kind of flexible subpod, n sandboxes in a pod with containers mapping to one of those is the best approach. However, the pod model is definitely the most consistent with today's models, and as a result will be much simpler to implement. It's particularly nice around the networking piece, and general resource sharing is much simpler through this model. And so this is kind of like the preferred default if we can dismiss the use cases for sub-pod isolation. And just to kind of recap what some of those use cases are, any situation where you want to run a sidecar that might have higher privileges or higher trust than another container in that same pod, you might want to have the the container that has the lower trust or lower privileges not be able to escalate through that privileged sidecar. And so being able to isolate the lower privileges one from the other one will get you more security. And just kind of one use case that we've heard a lot for that is the SaaS model, where you're have some sort of untrusted user code that might be running in a container in a pod, and then you have some support containers running as sidecars to provide services either to the user code or kind of to manage that code on the back end. So are there any comments around that?
I guess how realistic is it that we can eliminate the need for the subpod use cases? Like, are the areas that are being looked to be integrated that need to have higher privileged sidecar containers so indoctrinated in the community that a change there is impractical?
At least the use cases, what we know, but Derek, I don't know the image building use cases last week you mentioned. I don't know that.
Yeah.
But our internal use cases, people talk to with the subpod we discussed, and I think I have some counter argument, kind of convince people say that's not really impractical. We can provide that. At least that's the so far story. So that's why I'm kind of looking forward to waiting for the image building use cases.
Yeah, I was traveling at the end of last week, so I didn't get a chance to send that out. But I guess for the other ones that had been identified, I thought the service message meshes, like talk, were the other use case that were called out. And I don't know if, independent of the image building scenario, if they were actually able to work outside of a privileged sidecar container, that, like, obviously the pod model is the simplest, right? And the subpod model obviously makes me concerned just in complexity and trying to think things through. So, but I didn't know if there's been any further on discussion on, like, are we having to make a choice here based on, like, the state of the broader community today, or do we know if, like, folks who are asking for privileged sidecar containers have a way to not require them, or what other tools could we provide to avoid making them think they need a privileged sidecar container?
Yes. And another thing, also open question, what I have, can we start with the pod? Can we have that API, we can extend it and start with pod, then later, and then we can it's open to introduce the subpod. And it looks like so far, at least from API level, it's not that easy to do. And that's also makes these problems much harder. So
Like on the image building side, I'll try to get the details sent out. The other way that we were looking at this was, like, folks typically want access, like, to the Docker socket or some other highly privileged socket. And the way that you can get around that is potentially using something like a device plugin that gives you access to, like, a proxied socket, where you can provide the necessary sandboxing you thought you needed. And so that's one avenue that has been explored, but I wasn't sure, like, even if in the image building scenario, if there was a workaround, if the other folks in the community who had the other workaround had the needs, had other viable workarounds. Because looking at the list of pros and cons here, like, it's hard to evaluate in some cases without a clear understanding of, like, who the customer is you're serving and why they think they need this.
Yeah, so those are good questions. I think the kind of the general path forward here is to reach out to any customers that want this and better understand the use cases and the requirements and kind of brainstorm what the alternatives are. I think there's a few approaches to kind of, thinking about the service provider model. There's approaches where, instead of running a sidecar for every pod, Instead, you run, say, a daemon set on each node that kind of provides the same behavior. Now that needs to be able to multiplex across different user accounts potentially. So it adds some complexity there, but isn't undoable. Other approaches are using kind of affinity-based pods. That runs into some challenges with kind of lifecycle management, making sure that those pods coexist in the right ratios and whatnot. And then the other approach is to just say, these don't actually need to be co-located. If you want to provide some sort of proxy in front for the traffic, just provide that as another service in the cluster that then redirects to the user pod.
So Tim, do we have a clear list of reasons why we think those sidecars in most cases need to be privileged and cannot be?
So this is the other piece of it, which is some of the use cases that I've heard are, oh, I'm running a third-party monitoring sidecar that I don't trust the vendor or whoever. But in that case, it's a monitoring tool, and it needs pretty high visibility into the main container, and so it's hard to isolate there. Similar around, like, say, the Istio proxy. If you wanted to say that that's from a different trust domain, I want to make sure that that can't inspect my data or whatever. Well, actually, all of your traffic is going unencrypted through that Istio sidecar. Yeah. So you don't trust that. So yeah, it's a good point as well. Another option that I've sort of been thinking about yesterday and haven't had a chance to talk through the details yet is having a single sandbox per pod. And so this is kind of a simplification of the subpod model where there's one sandbox per pod, and you can say a container is in or out. And so this sort of supports that the containers outside the sandbox are isolated from the ones within the sandbox can't see the outside containers. And I was wondering if that potentially simplifies the networking model.
It does, but it breaks the current design of or concept of a pod, right? Because basically you will have pods, you will have containers inside the same pod that don't see each other.
Yeah, definitely. So this is another sort of broader question, which is how backwards compatible we want sandboxes to be. And it is a new concept that we're introducing, and so there's some opportunity to say, okay, we're going to actually change the semantics of, around the sandboxing and say this is a new concept. Things in the sandbox and things out of the sandbox only share the network layer. They don't share the other resources. That is an option. Right now.
One thing that I also wanted to point out for the subpod case is device assignment and device pass-through, where you could end up having a privileged container inside a pod, not having access to some physical resources that the other containers, the unprivileged ones, can access. Sorry. So this is it. It's kind of so you have this privileged container here, the sidecar ones that do not see the hardware resources that the unprivileged one have. So it seems a little awkward to me.
Sorry, I didn't quite follow that. Are you talking about the model that I just threw out of?
No, I'm talking about the subpod in general, or even, that would even apply to the model that you referred to, where If your sandbox container requests access to, or do have the direct access to some sort of device through pass-through or any kind of virtualization technology, your sandbox containers would see the device and would get direct access to the device, but the privileged container outside of the sandbox would not. So they are privileged, but they can't physically see some of the resources that the sandbox one do see.
Mm-hmm.
Kind of like a reverse priority type of.
Yeah.
Yeah.
So that may not apply to the sidecar use case, but if you define a subpod, then you basically open this possibility of having privileged containers not seeing physical hardware resources that the unprivileged one do have direct access to.
Mm. Yeah.
Mm-hmm. Yeah, that sort of raises the question of whether containers running in the sandbox should be allowed to be privileged at all. I think one use case for that is, if you're running a VM-based sandbox, say Kata containers, maybe you want one of the containers within that sandbox to be able to muck with the guest OS or some resources that aren't exposed to non-privileged containers within that.
Yeah. There are actually a lot of use cases for this, so this makes perfect sense. You want some of the containers to be able to load kernel modules, for example.
Yeah.
So that is a valid use case. But there's privilege and privilege in that use case where your container would be allowed to mess with some part of the guest OS, but would not be allowed to see anything from the host OS.
Yeah.
So it's a reduced privilege container, I would say.
Now, enabling that privileged capability, it exposes more of the underlying implementation. So if you say, I want to be privileged so I can install kernel modules, what happens if the sandbox is not based on a traditional virtual machine model? I think this is kind of generally true. Like, if you're running just a regular pod without sandboxes in today's world, and you're running privileged and doing things with the host OS, then you're adding some dependencies on that host OS implementation. So this is kind of a more general problem there, but something to consider here as well.
Tim, I guess it seems like fundamentally we're just deciding on use case 7, sidecar container having distinct privileges, and I think there's a lot of speculative value that you could tie to that use case, but I guess I get nervous that we're many years into the project, and then adding this at the later date seems like a big fundamental change. And so, I feel like I want an overwhelming number of things that are unlocked if this is done. Where right now I feel like it's a lot of it's more speculative, oh, that would be useful type of thing, but not necessarily calling out that it's fundamentally required. Could we have, I know I can enumerate the OpenShift image building use case as one example, and then we've spent a lot of time trying to think about how to get out of having that need. But is anyone, for the folks who are demanding the change, is there a way that we can just collect all of the use cases that have been presented and see why or what alternatives were considered? And maybe you have seen that and it just hasn't been distilled in this doc, but it seems like This just seems like a huge change, right?
Yeah,
I agree.
I agree as well.
It's like especially all those use cases I heard so far, and I have the long discussion with the team, and at least every single one have the counter argument.
Mm-hmm.
So I think there's either they need to change their architecture, or it is they ask some like the use cases beyond Kubernetes could offer.
Mm-hmm.
At least from the so far discussing. So I was the only thing is like I don't understand the OpenShift use cases. So I'm looking forward for that one. So then we can continue discussing this. So far, none of those is kind of the worst that complexity and redesign Kubernetes pod concept, at least today.
Yeah, so I was just wondering, like, if as a community we could have a place to gather all the areas where we think this might be useful and just have a way of labeling them. Like, even if that meant we go and create issues, or we just go and send a note to the Sig Node mailing list, or whatever directory that holds this proposal of yours, Tim, like, we just open up a folder and let people go and fill in where they think the use case is required. But, like, I'd be happy to go and extend 7 and say, like, you know, like, take a step back and ask how this would help or not help us for an OpenShift, you know, image building use case. But like, even though there are areas where it could help us, it just feels like this would open up a bit of a Pandora's box that just concerns me.
Yeah, I really like that suggestion. I'll follow up on that and figure out a way to start kind of collecting and enumerating these in a way that we can also kind of discuss the alternatives and figure that out. One thing I wanted to mention is this one thing I like about this kind of metapod point is the idea was that we can basically start with pod level sandboxes and you know, say the sandbox is at the pod. This fits the vast majority of use cases. We're not sold on the sidecar use cases, kind of what you were just saying. It's consistent with the current model, and move forward with that. And then if at some future later date we find that actually there are an overwhelming number of use cases for the sidecar isolation, then we can extend this by sort of building up and building this, you know, some sort of sharing model above the pod, which is a big change from the current model, but at that point it would have to be kind of what's the word for it? It would have to have the driving use cases at that point. And so this is this idea of, like, you know, we can build that on top of the pod instead of kind of starting with that and building it underneath the pod layer. So it's not like if we choose pod as the sandbox model, then there's no path forward, or we have to kind of redo the API or something. Yeah.
The only concern it is just introduce the dependency between of the pods, which we try to avoid from the beginning. And but it looks, this is the one possibility we can go forward if we just decided the pod. And now, the problem it is we talk about, we discuss, let's start with the pod, then we think about from pod extended to the sub pod or container. The API is kind of it's not that compatible. It's much easier to go forward. So the metapod actually could be at API level. If we think about that, kind of if later we want to start something like similar to the subpod, then you can redefine your pod and then put it into the metapod. And so then, which means right now we need open to the path for the metapod at API level. That's also is like the API design approach.
I just want to say that, like, when we extend the pod concept, I mean, that's it really does add a lot of cognitive overhead to working on the kubelet. When I see this, I think about init containers and how those were simple to reason about, like, just conceptually. But man, in the code, they really make it difficult to work with because they have to be executed sequentially, and they can fail, and they restart, and what order do you do them in, and they're supposed to be idempotent, and it really complicated the state machine in the kubelet to where it's almost difficult to determine what the pod phase is, and we're still working out bugs with that, and so it's really tricky.
Totally. And init pod, init container is already the simplest cases among all those things. Yeah.
So yeah, I'll take that action item to follow up on those use cases, but I think the kind of overwhelming consensus at this point is pod is the simplest approach and definitely the preferred approach, unless we get that overwhelming feedback that we need a different model. But that was a pretty good transition into talking about life cycle. So one of my concerns with adding the sandbox pod concept is the pod now becomes more than just a collection of, more than just kind of an organizing concept in the kernel. You now have potentially a guest OS running in that pod sandbox, which means you now need to sort of maintain that life cycle of the pod in a little more detail. And so one kind of example I gave somewhere in this document is, you know, if you run into a kernel panic or an issue that causes that guest OS to fail and you need to restart the pod, how do we surface that in the API? How do we deal with that? And one potential answer, again, this kind of simplest answer, is that should be very rare. And if it happens, then we just treat it as a pod failure and wait for a controller to delete and recreate that pod potentially elsewhere in the cluster. That has a lot of overhead, a lot of latency, but again, if it's sufficiently rare, that should be negligible. Yeah.
One question, Tim. For which reason should we handle that use case differently than just a regular pod failure? So why would you handle a guest kernel OS crash differently than just a regular pod failing and having the controller restarting it? But is your concern mostly about latency and restart overhead?
Yeah, so today pods fail if, correct me if I'm wrong, but my understanding is that pods fail when a container without a restart policy fails, basically. Is that right?
We always have the restart policy. It is depend on the policy. Like the restart the policy is level. Mm-hmm. And there's a couple of things you may fail the pod, but the majority of cases is restart policy. It is level. And I think the Samuel. I think what team is here. It is because the possibility with today's sandbox technology. So you end up after you running the pod. There's the VM. And so there's the introduced new failure mode. The VM is failed. So how we are going to capture that fail model? Because in today's model, it is Kubernetes already know. Kubernetes decided to set that pod fail. So have the full view about that pod and the container, right? So it's not opaque to the Kubernetes today's situation because it's all run on the same operating system. But in this today's sandbox technology, what we are talking about mostly is we are talking about the hypervisor solution and the VM solution here. And so that's opaque to the Kubernetes. So how we are going to manage it in that case, this is more problem. It's not really, it's not really pod life cycle. Mostly it is just extra failure mode.
Mm-hmm. That's also because we're thinking of about the solution space and thinking about in terms of VMs and hypervisor, but if we introduce a sandbox concept, shouldn't we also have a sandbox lifecycle with a failure for sandboxes to be handled as well by controllers?
Yes, that's also what I'm thinking. Yeah. So, but this part actually is not clear so far.
Okay. Yeah, I see.
Yeah. Again, so if we went with a sub-pod isolation model, then there's a lot of life cycle. CRI needs to be extended and whatnot. If we're talking about sandboxes at the pod layer, then yeah, the number of changes are a lot smaller, but still some changes that need to be made around how the pod lifecycle is managed. As Don was mentioning, we're kind of adding new failure modes. And I need to take a look at the CRI. But I don't think there's a way for, I don't think all the hooks are there right now to handle this concept of a pod failing independently of the containers within the pod. And so yeah, so kind of the simplest approach is just, a pod fails, that's it. We mark it as a failure and let the current lifecycle handling take care of that. If failures are more common, then we might want to add the ability to restart a pod in place. But this has a lot of challenges around dealing with the init containers and all of the kind of more persistent state that goes along with pods and how that's handled.
So for what it's worth, if we're thinking about sandboxes as virtual machines, typically the guest kernel would be either very similar or at least maintained by the same entity as the host kernel. So I think it's a safe assumption that to assume that the failure rates would be fairly identical between the host and the guest kernel, because you're going to have it's basically going to come from the same sources and the same OSVs and so on. So if we're looking at rates of failures, I think this is the kind of numbers that we're looking at. The host and the guest kernel should, in theory, have the similar failure rates.
So Tim, another question I have, and I'm just jogging 3 years of horrible discussions. When you discuss the sidecar container with distinct privileges, is that separate in your mind than, like, I've had some requests of folks want to run init containers with higher privileges than the other containers. Do you think of that as a separate use case or something within the sidecar container use case?
Yeah, that's a good point. That, even if we go with the sandbox at the pod layer, there's kind of an opportunity to say, well, init containers could run outside of the sandbox.
I'm trying to search my email from when I was asked these questions of running higher privileged init containers and then being able to drop down privileges on your normal container.
Yeah, Istio is an example that I know off the top of my head. They run an init container that sets up the IP tables rules in the pod network namespace to redirect all traffic to the Istio sidecar. And then that sidecar actually, because the IP tables rules are already set up, that sidecar doesn't need any extended privileges.
So I guess, do you think of them as equivalent use cases then?
Yeah, I guess it's worth separating those out. From a use case perspective, I think from a user perspective, they're similar, but from an implementation perspective, there definitely are some differences there.
So I guess if I understood the scenario you described right there, having a privileged init container allowed you to avoid having to do the privileged sidecar, correct?
Yeah, right. Although I wonder if the Istio case would work if that privileged init container was still in the sandbox. I don't know enough about, I don't know, maybe Sam could answer this question of whether you could set up IP tables rules in the guest OS in a Kata container to direct the traffic to the sidecar. Does that make sense?
It makes sense, yes, and yeah, privileged containers inside the guest OS should be allowed to do that.
Yeah,
but it's I mean, we need to understand if setting the IP tables inside the guest OS would be sufficient for this specific use case.
Yes.
So maybe we can play with that on our side and see if we could set up an Istio pod with Kata containers.
Yeah, that'd be interesting.
Yeah, I'll look at this.
Maybe another use case would be around initializing a device if it needed to be, if there was some initialization that had to happen outside of the sandbox for that device is passed through or emulated.
So that would be done by the device plugin itself, right?
As long as it's something generic.
Yeah. Actually, that was a question I had around. I think Sammy left a comment on how devices work with Kata containers of either their. My understanding was either emulated at the driver interface or emulated at the hardware interface. Is that, am I understanding that correctly?
So you have two possibilities. Either they're emulated and you typically get a Vertio device showing up in the guest, and your hypervisor does the emulation, but it's an emulation on the host where the hypervisor talks directly to the hardware to go to send commands and packets. That's the least performant way to do that, and the more performant one is the hardware virtualization for devices, where you can directly and securely assign hardware resources directly into the virtual machine. And there is no emulation at all.
Okay.
So when you do a Docker --dev on your specific device, we use the latter for supporting this use case. When you don't, you only want a generic network interface, we use the former.
And are either of those kind of agnostic to the device? As in, could you
no, so the first one is agnostic. So it's you're just going to see a Vertio device, which is not even branded. It's a Red Hat PCI ID. But if you do the direct device assignment, you literally get access to the hardware resources. So you see all the PCI config space and everything, and you see the entire device, the real one.
So thinking about device plugins, if I wanted to run a arbitrary device plugin and have it work out of the box with something like Kata containers, it sounds like that would be possible.
Yeah, definitely. So your device plugin is basically going to enumerate and initialize the device on the host, and talk with Kubernetes for doing so. Mm-hmm. Once this is done, it's just another device that's either you pass directly into the virtual machine through hardware virtualization, or you emulate through something like Vertio. So from a Kata container perspective, there wouldn't be any much of an interaction between the device plugin and the sandbox. It would just be another device that shows up on the host. Okay.
So I think we've touched on all the questions that I had for this group. Does anyone else have any other related topics or questions they'd like to raise?
Last week, the Harry gave a talk, share a doc also about the option of how we are going to integrate with the CRI. So there's the 3 options. So we didn't. So I'm not sure how many people reviewed that one. I'm not sure Harry it was here, but I think that Samuel you can represent because it's also talk to the Kata container integration. So did you guys got enough opinion, suggestion?
Sorry, I was on mute. Don, are you talking about the CRI multiplexing thing that Harry presented last week?
Yes, I'm talking about that one. So we request of the community review and give opinion. This is more like the implementation detail underneath, but also we need to make progress. So there's the 3 option is listed there, and so one it is just point to the Kubernetes to make all the decision and option, and another one it is introduce another CRI like a proxy, like all things decide what kind of the CRI you want to invoke based on the secure container option. And the last one it is which I most prefer, but I'm not sure. So it is just needs to not introduce the new container runtime in fleet. Instead, okay, we already have the 2 so far, or maybe more, and that one. But like this is kind of go extra feature to those container runtime. Like for example, extra feature to the CLI container D, extra feature to the file. Can we carry that kind of thing? There's some discussing, and those have the pros and cons. And I just want to make sure this is called out to the community and the opinion.
I think one important input that it would be for us to get is the CRI maintainers, or the CRI shim maintainers view on this. So what do people from Cryo, CRI Containerd, and Fracti think about this, and what would be, because in all 3 cases they're going to be implementing the changes. In some cases less than others, but it would be interesting to get their opinion on this.
Yes.
So, hey, Mrunal here. So I think I like the way the integration works in Cryo today, because it's a single daemon and we're using the OCI layer to communicate with clear containers Kata. So that way we don't have to maintain or run 2 different stems. We just have one daemon to worry about. And as long as, clear containers understands the OCI calls, we can just plug in and run C or clear containers or any other OCI compatible runtime.
So I believe the CRI Containerd have like the similar stand. So I personally feel this is more like the Kata container perspective. So how easy to integrate first thing, and is there any like the actual functionality we want to preserve? So then we want to have the complete of the runtime. Instead, we have like underneath only like OCI compatible layer. Like you could have the clear container, or you could just directly say based on that one, say I understand there's the secure container, and then invoke runway or invoke run C. So that's kind of the decision we need to make. The reason I think even this is implemented detail, I still want to have the basic agreement. It is because we are affect the API, and also the which layer have to handle that API, how we are going to pass that deep knowledge to.
Yeah, you're going to affect the kubelet implementation as well, depending on which option you choose. Yeah, if you go with supporting several CRI implementation on one node, you're gonna, for example, kubelet should be made aware of which CRI implementation supports which sandbox features. So there's implication there on having CRI implementation registering against kubelets for capabilities, for example.
Yeah.
So, yeah.
one concern I have for the model option C, which I try to push hard, but I do have the concern. It is when we deliver those kind of solution to the production, how we are going to coordinate those kind of things. Like there's the Kubernetes release, there's the runtime release pushed by the runtime vendor, and then there have the actual of the sandbox solution release, and how we are going to coordinate, how we are going to deliver, and that's kind of the concern how from my side. But besides that, there maybe have some kata integration related of the complexity I want to understand.
So wouldn't be wouldn't the sandbox features be made part of the end-to-end testing, for example? And
yes.
And if they do, then in production, before deploying your latest version of CRI Containerd or Cryo, you would know if this specific CRI implementation supports the sandbox features in one way or another. This is transparent to the user, but at least this would be a guarantee that your CRI implementation supports this.
Yes.
Supports the sandboxing.
Yes. Yeah.
And the rest becomes implementation details.
Yes.
There are a number of features in the CRI that are considered optional, and I think we've discussed before whether we need an API to kind of report what features are supported by a given
we do.
Implementation.
We do say that there's the CRI vendor can publish those kind of what kind of feature you support, and then Kubernetes can propagate those kind of things.
I think we're about out of time. I did want to quickly mention, I'm hoping that we can nail down a lot of the design decisions around this in the next month, and then get this into Kubernetes as an alpha in 1.11.
Okay. I think that we have over 2 minutes.
Yeah, there's not really enough time to talk about this subject. We should bring it up in the next call.
Okay, sure. I will make sure next release we are going to talk about this more. Okay, so thank you for everyone and for attending the meeting. And I just realized it's Chinese New Year. Happy Chinese New Year.
Happy New Year.
Holiday.
Thank you. Bye, everyone.
Bye-bye.